Today we're going to look at the first half of section 5.4, and that is on completing the square, so solving quadratics using this method. The first thing that we need to talk about is the square root property, and that simply says if we have our quadratic equation simplified down to just x squared on one side, that we can take the square root of both sides and we can have our answers. So in the middle here, it shows x squared equals 15, so we take the square root of both sides. Remember that when you take the square root of a number, there's a positive number, positive answer, and a negative answer. So for instance, square root of 36 is 6. It's also negative 6 because negative 6 times negative 6 is positive 36 as well. So you can't forget the negative answer. So that's why that little plus sign with the underline, that's actually a positive negative sign. Is in front of that. So for example 1, we're going to solve each of these equations. So our first one, we need to do an upside down t, and we need to isolate the x squared. So we're going to add 4 to both sides. So we're going to have 3x squared left here, and 68 plus 4 is 72. And then we're going to divide by 3. So we're going to have x squared left on that side. And 72 divided by 3 is 24. And then our last step is to take the square root of that. So the square root cancels out the squared. So we have x equals, we can't do, the square root of 24 is not a perfect square. So we're going to write positive and negative square root of 24. We can also simplify that. 24 is 6 times 4. And we can do the square root of 4. So the square root of 4 is 2. So that 2 would come out and be in the front of the radical sign. And that 6 is not a perfect square, so it would stay inside. And then we have our positive and negative. All right. For our other problem here, we have to factor this first. So we are going to, what I see is that I can take the square root of the front, this is a 1, and I can take the square root of the back. So if I do that, I have 1 times 1, so x times x, and 25 is 5 times 5. And remember to check our answer. We do 2, it's always 2 times 1 of the front, which would be x, times 1 of the back would be 5. So 2 times 5 is 10. We have an x, so that does check out. So our answer is x and 5. It's a subtraction because this is a subtraction problem here, squared. So we have 2 of those. And that equals 27. So I'm just bringing this 27 down. So I factored the left-hand side, brought down the right-hand side. Now to cancel out that squared, I have to take square root. So x minus 5 is left here, and the square root of 27 is not a perfect square, so it's a positive or negative square root 27, and I have to add 5 to both sides. So we have x equals, and I always put that number, I don't put square root of 27 plus 5 because sometimes it looks like that plus 5 is under the radical and we don't want to have that happen. So that 5 is positive, so I'm going to put it out front as a positive 5, and then plus or minus, so positive or negative square root 27. So that covers both of our answers. We could also break up the square root of 27. Square root of 27 would be 9 times 3. The square root of 9 is 3, so that 3 would go outside, and we would have that other 3 left inside. So we could write our answer as 5 plus or minus 3 times the square root of 3. All right. And then completing the square is just adding a term to form a perfect square. So to complete the square, we are going to add b over 2 squared to our equation. So remember that our quadratics are in the form of ax squared plus bx plus c. So when I do b over 2, or b divided by 2, b is the term or the coefficient that is in front of the regular x. So here, if I have to do b over 2 squared, b is in the negative 2 there. So negative 2 over 2, and we have to square that. So negative 2 divided by 2 would be negative 1, and negative 1 squared would be 1. So completing the square there, we would add 1 to it. Now over here, b over 2 squared, b in this case is going to be 5. So 5 over 2 squared. 5 divided by 2 isn't going to come out to be a whole number. So what I'm going to do is I'm going to square both numbers. So 5 squared is going to be 25. And 2 squared on the bottom would be 4. So that squared gets to go to both numbers. And then we are going to leave that as 25 over 4. And you'll find out tomorrow or the next day why we want to leave that as an improper fraction. So those are the two things that we're going to focus on for today.